Hi guys, today we're going to be doing derivatives of exponential and logarithm functions. So in section 3.2, this first part of the notes is just kind of a recall, hopefully a review of what logarithms are. So if you have something log b of x, that's the same thing as saying b to the y equals x. Most of this part is not going to be, most of this section is not this part of logarithms. It's going to be taking derivatives of it. But I kind of always remember it's like a circle. So you go b to the y and then equals x. 2 to the 3. So that would be log base 2 of 8 is 3. Because another way of thinking about it is 8 is 2 cubed, and log base 2 and 2 would cancel out and you would get 3. It's kind of a way to return what power, if this is the base, what power am I raising this base to get 8? So you can read that part there. These are some important rules of logarithms that we need to know. Log b, any log of m times n is the same as log m plus log n. So log of the product is a sum, and then log of the quotient is a difference. And then this is an important rule. This is not the derivative, although it kind of looks related. You're not subtracting one, you're just pulling it in front. And that's a scalar multiple rule. And it's important to know log of any of one, if log base to any base of 1 is equal to 0. True for log b represents any number, or natural log. Natural log is log base b. Hold on just a second. Okay. We're going off. Okay. So let's get back to this. So for derivatives, that's the important part, the calculus part. The derivative of e to the u is e to the u prime, or e to the u du. And I'm going to show you, just go ahead and show you an example underneath that so you can see it. So if I had e to the 2x, the derivative of e to the 2x would be e to the 2x times the derivative of this, which is 2. And you would write that as 2e to the 2x. The derivative of e to the 3x would be e to the 3x times the derivative of 3x, which is 3. So 3e to the 3x. If I had e to the x squared, it would be e to the x squared times the derivative of x squared, which is 2x. So you're always going to have e, whatever the e is, e to the 2x, still e to the 2x, e to the 3x, still e to the 3x, e to the x squared, still e to the x squared. You're going to have that appear in the answer. And next to it, you're going to have the derivative of the exponent. The same is true. It's a very similar process for when you have another exponential function besides b. It's just you have to multiply by the natural log of b. So say I had 7 to the 2x. The derivative of that would be 7 to the 2x times 2 times the natural log of 7. Or if I had 3 to the 5x. 3 to the 5x, just like e to the 5x would be e to the 5x times 5. This is 3 to the 5x times 5. That's the derivative of this. But then times the natural log of the base. So what if I had 4 to the x squared? It would be 4 to the x squared times 2x times the natural log of 4. So that's what this formula is saying. And then when you have log of anything, I just always remember this non-math way of saying it, but it's the derivative of the stuff over the stuff. Derivative of the stuff over the stuff. So that's u prime over u. And if you have log base b, the extra part is you divide by the natural log of b. So for instance, if I had log of x squared plus 1, the derivative of this would be the derivative of this stuff, which is 2x, over that stuff. If I had log some other base, say I had log base 5 of that same problem, it would still be the derivative of this stuff, oops, not 2x here, just 2x, over this stuff. So the derivative of the inside, the argument is what that's called, over the inside, and then you divide by the natural log of whatever this base is. So those are those rules applied. So go ahead and take a moment to copy those down. You can pause the screen if you need to. And then we're going to move on to our examples. Sorry, I don't know why I stopped sharing the screen. Hold on. Okay, so let's go down to example 1. So 3e to the x is just going to be 3e to the x. Pretty easy, because what's the derivative of x? 1. So I don't need to multiply by 1. It's just the same thing. This one, 2 to the x, that's the a to the u or b to the u rule. So I rewrite what I see, multiply by the derivative of that, which is just 1, and then the natural log of this base, which is 2. That's the derivative of this, minus the derivative of natural log of x. This is your stuff, if you will. So the derivative of x is just 1 over x itself. The derivative of 7x is 7 minus 9e to the x plus the derivative of this. So we take the derivative of x, which is 1, put it over itself. And then because this is another base, besides just natural log with the base e, you divide by the natural log of whatever that base is. So those are the answers for these first 3 examples. Example 4. Okay, so we have 2 options here. We could rewrite it. We could bring this 8 down using that logarithm rule. And then take the derivative. So it'd be 8 times the derivative of this, which is 1 over x. Or we could do not rewrite it, and we could just take the derivative of 8x to the 8th, which would be 8x to the 7th, and put it over x to the 8th, and then simplify, which this you would subtract. So we still have 8 over x. Either way, you get 8 over x. This one's kind of tricky. E to the e times e to the x. There's a couple ways you could do this. You could write this as e to the 1 and use exponent rules and write e to the 1 plus x. And so the derivative of this is just e to the 1 plus x. You could also just keep it like this. And the derivative of this, if I had 2e to the x, the derivative would be 2e to the x, because you multiplied by the derivative of this exponent, which is just 1. If I had 3e to the x, it would be 3e to the x. If I had 5e to the x, it'd be 5e to the x. So if I have e to the x, it's just e to the x. What changes is if there's not just an x here. If it's if it say it was 2e to the 2x, well, that would be different. That would be 2e to the 2x times the derivative of 2x, which is 2. So that would be 4e to the 2x. So that's at that argument. I mean, the exponent is different. Let's look at example number 6. So for log base 2, we're just going to, the -5 just stays in front. It's just a coefficient. The derivative of this, you take the derivative of the stuff, which is 1 over the stuff. This is a different base than natural log, so you have to divide by the natural log of whatever that is. The derivative of ln of x is just 1 over x. The derivative of 4 to the x is 4 to the x times the derivative of this, that's just 1, times the natural log of the base. So that's our answer. You could write, oops, that should be 2. Write it like this, where you combine the fractions. That's fine. Okay, if you have a log where you have a quotient, I definitely would rewrite it. Otherwise, you're going, when you go to take the derivative of this, you would have to use a quotient rule, which if you recall, it's the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared, and that would all be over this. So it'd be like a 4-layer thing. It would be a fraction with a fraction in the numerator and a fraction in the denominator. That does not sound fun. So instead, we're going to use that property that's on the top of your notes. That says if you have natural log of a over b, that's the same thing as natural log of a minus natural log of b. So we're going to rewrite this as just subtracting those two things. Okay, and then we're going to take the derivative. Well, the derivative of natural log of 3 is just 0, because this is a constant. There's no x here. The derivative of minus natural log of x squared is minus derivative of this, which is 2x, over itself, plus the derivative of 4x, which is 4 over 4x. So this actually simplifies to be -2 over x plus 1 over x. And so then that could actually simplify. You could do -2 over x plus 1 over x because they have a common denominator. So -1 over x. Find the equation of the tangent line. Anytime you see that phrase, I hope you recall, when you see find the equation of the tangent line, what 2 things do you need? Equation of the tangent line. Hopefully you're saying point and slope. Our point is E, comma, something. The way you find that something is you plug E into F, the function, though, to get the Y value. Now, when you have natural log of E, they cancel each other out. Like natural log of E to the X, you get back X. So natural log E to the 4th, you just get back 4. So we have 1 plus 4, which gives us 5 as our Y value. The slope in calculus means the derivative. The derivative of 1 is 0. The derivative of natural log of X to the 4th is 4x cubed. The derivative of this stuff over itself. So if this simplifies, this would cancel and you'd have 1x on the bottom is 4 over x. Then I need to plug in E, that's my slope at this particular point. And then you just write y minus y1 equals the slope times x minus x1. So y minus 5 equals the slope, which is 4 over e, times x minus e. Anytime you see equation of the tangent line, don't freak out. You just need a point and you need a slope. Those two things. Okay, attempt your assignment. As always, I'm here to answer questions.